All right, everyone. Welcome to lab number 9. Today we are going to be doing regression. So it's fairly straightforward what we need to do, and the lab is very short today. The homework is a little more involved, but if you are able to do the lab, then you'll have the skills that you need to complete the homework just fine. So first thing you'll see is there is data in the Word document that you will use for class that is uploaded on Blackboard. So you're going to take that data, put it into Excel by copying and pasting the columns. Take note of the names on the columns and feel free to rename them if you prefer, if that will make it shorter. Or easier for you to remember. But yeah, you're going to copy and paste that into an Excel file. I'm not showing you how to do that here because it's fairly straightforward and easy what to do. And you'll go through the normal process of import dataset from Excel, pull it up. Let me actually go through that again and show it again. Documents. And click import. And we have our two columns. I have them as educ and child. And that forms the basis of what we need to do. So that will take us through step A. And we're now ready to do step A. So we're going to start by making the scatter plot. For that, you're going to need the ggpubr attachment. So go ahead and do library ggpubr to get that ready and active. And if you do not have that package already, you will need to go and download that package. Now, the syntax of the plot is you're going to use ggplot, which is part of the ggpubr suite. And so you're going to do parentheses, and then you're going to type in the name of the document. So I'll show you that ggplot, parentheses, and begin to type in the name of the document you just uploaded. You're going to do a comma, and we're doing AES. Do a single parentheses. You're going to use the names of the two columns. You do not need to use the dollar signs for that. Now, this next stuff is a little tricky and confusing. So you're going to put a space and then a plus. You're going to go down to the next line and do GEOM underscore point. You do not need to put anything inside those parentheses. Put another space, another plus. And down the next line, stat underscore smooth. And then method equals linear model. And then take all of that syntax and hit run. And you'll see the plot pops up over here on the right. You're going to copy and paste that in. So copy image. And I know it's not showing you guys, but you're going to paste that. Okay, paste it as a picture. And it says, then use R to complete the regression components, the slope and the intercept, write the regression equation, copy and paste your R syntax and output in your worksheet, compare your results to question 1, and state the results in APA format. That seems like quite a bit, but it's actually really not that hard. So first thing, you're going to do view and the document that you just did. That makes sure that when you do the when you assign the variable that you need and do a linear model, that it will reference the right thing. So in this case, we just created a variable called model. If you wanted to, you could call this LM, whatever you want to call it. You could call the letter A, doesn't matter. So the main thing that matters is whatever you're going to define, you're going to use the little pointy arrow, so the arrow and then the dash or the equal sign, and then the syntax you need is LM. Here, I'll actually type it out so you can see it. Model. It's going to be defined as LM, and we're going to use child onto education. Data equals edu on child. I'm going to hit run. We've now defined model as that, and then we want to see a summary of model. This is going to give us all the information that we need. Whatever we defined there, so if you called it M, you would just type in summary M. Okay, so we hit run, and look at that. See, it starts with call, LM formula, da-da-da. You got some residuals, you got some coefficients, you see intercept. You see this value here as well, right? So we have the information that we need in order to do this. So it says, then use R to compute the regression components, the slope and intercept, right? So this is your intercept. So by default, this is going to be your slope, right? Just as a refresher, you're going to do y equals your slope minus 0.32 x plus 6.09. And that is your equation, right? And copy and paste. Well, you'll just type that directly into your Word document. For greater accuracy, you might want to put more decimal points. That would be helpful for later on. So copy and paste the syntax and output. So we're going to copy and paste what we did. Hit copy and paste into our Word document. And it says compare your results to question 1 and then state the results in APA format. I'll show you guys the APA format in a little bit. But if you take a look at what you've got, first of all, the slope is negative, and you can tell from the plot that the slope is negative. It goes down. It's got a slope of about 1/3, which means, remember that whole rise over run thing? So every 3 across, it should go 1 down. And that is about what our line looks like there. So far so good. and it looks like it starts at a positive point on the y-axis and moves down. So we look like we're in a good place. And the last thing to show you guys in R, it says use R to complete the mean of the variables and check to see if the best fitting line passes through the point. Indicate the point on your scatter plot. For that, we're going to do, we did summary model to get that information, right? This information here. That gave us our slope and intercept. So now, instead of doing summary model, we want to see the summary of the data set that we uploaded. So we hit run and look at that. We've got our means for both columns there. So that's the means of the variables, and then I'll show you guys on the Word document how to check those things. Okay, great. So now that we have gone ahead, I've copied and pasted everything over into the Word document. So you see the original data set, made the scatter plot, copied and pasted my syntax and output, and I created the regression equation. You see here, included a little bit more decimal places for greater accuracy. And so here's our write-up. The number of children is significantly predicted by parents' education. This is your slope. B is slope. T 23, P is significant less than 0.05. For these values right here, you could see 23 degrees of freedom is listed right there. And let's see here. You pulled that T value from here. Okay, it's the third coefficient for education, right? The number of children is also explained a significant proportion of variance in parents' education. R squared, which is a type of effect size statistic, equals 0.22, which you can get here. Multiple R squared, 0.22. You see the F statistic, 1 and 23, 1 and 23. The 6.52, P less than 0.05. Great. So that's going to cover it for part B. For part C, now we're going back more to our stats class. So it says, use R to compute the mean of the variables. I've bolded them here so you can see those two means, and check to see if the best fitting line passes through that point. Now, so we have the equation and we have the mean points. So at this point, it's just like regular math. So we have a value for X and a value for Y. And those two things should sort of cancel each other out. Let's see here. If you look on the scatter plot, right, you see the number of children is the y-axis and the education is the x-axis. So education is x-axis, number of children is y. So y of 0.204, which means our mean, should equal negative 0.322 times 12.56 plus 6.078. And that should equal 0. So just kind of like go into whatever calculator and just plug it in and see what happens. It's 12.56 plus 6.087. That's 2.02 on the right side and on the left side. So we, it cancels out. 2.04 equals 2.04. We could say 2.042 because that's technically what the right side comes, or 2.043, but it's close enough, right? So we have checked our scatter plot and everything looks good. So what's the predicted number of children for a person with 16 years of education? Now, this might feel like, why am I doing all of this? You will probably need this next year for a major group project. So tuck this away in the back of your mind because this is important. So what's the predicted number of children for a person with 16 years of education? Well, for that, we're just going to take our formula, and then we're going to plug in 16 to here. Just pull out your handy-dandy calculator and see what comes out on the other side. All right. And so our answer is 0.935 children, which we can say on which is very close to 1 child. Right? I mean, you can't really have 0.935 children, so I'd say 1 is probably the correct answer to this question. And that's it. That's what you're doing. That is regression. That is the power of prediction that we can kind of get from having a data set and developing an equation based off of the correlation and the general trends that we see in the data. Pretty cool stuff. So good luck to you guys, and let me know if you have any questions.